Every- Hello everyone. In a previous video, this is where we stopped at. Our simulation time is still it's not okay, it can feel like further reduced. So we'll see how we can fix that hopefully in this video, right? So if you haven't subscribed to my channel yet, I invite you to subscribe and join my channel. Yeah, so we'll see how this problem that we have at now can be fixed. um, right, so let hit no. And the other change that I want to introduce is that let's do the simple thing first. We'll bring in the traffic lights, and and we'll see whether that will do reduce the simulation time. I have I already have it with me from a um like that has been generated by visiting actually the location, and the traffic counts that were collected is there with me. So then let's see whether I can bring it to this one. Yeah, so let me I'll create a folder called additional, right? You can do it either from the VS Code or from here, doesn't matter, right? So as the additional file, I'll add this traffic lights, and then we'll see. I'll show you how the traffic lights are, right? So this is how it goes, right? So this is carefully, uh, uh, we took video records, and then based on that, we manually counted the timings, and then uh, sort of updated the base signal timing values, and then basically updated this XML file, right? So that's how we created it. So uh, it's kind of captures pretty much all the important junctions and the associated signal timings. So then let's show it in our additional files. So we need to bring that as well as a additional file, so we can put it over here. So let's say additional files, additional basically I'll have to take this copy relative path and paste it over here, and then I have to then yeah, so then basically I have to close this. So this is saved. Now let's see if I can run this. So I should be I get an error. This is like I am aware about this error. So the error is, it says there's no initial signal plan for cluster, right? So a particular part of the network, it doesn't have its initial signal plan, right? So that was that error. So if I locate that particular junction, right? So this is that junction. So this junction doesn't have a signal timing plan. So I hit control letter T, and then create a signal timing plan. That's the base one. So you can save it, and then you can also close the network. And then if I reload it, it works as expected. So now this is now running on the on the updated signal timing plan. So whether we'll see whether there's any improvement. Um, I think it's improved. Let's see. So here you see overall very less number of vehicles are in the network. So it means whatever the vehicles that enter are cleared soon, right? So earlier you would have seen this value goes to closer to 1,000 vehicles. So or like this is the number of vehicles at a given timestamp. How many vehicles are there in the network? So I think it's better. Yeah. So it's clearing nicely. Yeah. So 4,600. So not bad. Not bad. Right. So yeah, so that is, I mean, so I guess majority of the problem was solved by changing the signal timing plan. The other setting is that at the moment I only have passenger cars in the net, right? So there's no vehicle type, different vehicle types. I don't have introduced yet, right? So the next job that I'm going to do is to introduce these vehicle types, right? So that can be done by using something called a vehicle type distribution, right? So if I may show it to you, so yeah, this is so something like this you have to create, right? So I think it's more like it's not actually properly I mean, the one that I'm going to create is not here, but it's something like this, right? So yeah, this is right. So this is what you need, right? So we need to define different vehicle types, right? Here type 1, type 2, it could be a car, van. In this case, in my country we have tuk-tuks, right? It could be tuk-tuks, and you need to give the relative probability, right? So that is the main point here. So I have created a file like that, matching the traffic conditions. So I'll paste that. So we type list base. So if I may show that to you, what you have is something like this, right? So we have, so this is an ID, and so we have the probabilities for each, like, car, motorcycle, van, three-wheeler, goods vehicle, etc., etc. So the main takeaway here is that you can give the probabilities, and also you can define the vehicle type parameters, right? What's the minimum gap, the length, width, the other calibrated potentially you can calibrate certain parameters. For example, looks like sigma, right? So that is how this works, right? So you have to find the composition of your vehicle fleet in your network, and then you can create a vehicle type distribution file like this. So I can add that as well. So if you add multiple types, you can, I think, comma separated and add them. Add this. So let me copy this and just change the slash. Right, that's also fine. So let's run one more time. Now you have different types of vehicles, right? So somewhat smaller vehicles, somewhat larger vehicles, right? So that will also, at the point which they stop at traffic, the minimum gap also comes into play, right? So have reduced minimum gaps. So that will also have an impact on the simulation timing. I mean, little things add up. We'll say how the end result is. So yeah, so let's see. Now the vehicles are clearing quite quickly. Yeah, so 4,400, 4,600. Right? So this is good for us. I mean, if you can reduce it further, that would be awesome. So, I mean, but you can't never bring it to 3,600, but you can come as closer to 3,600, right? So that that indicates that the effort that you have put some effort to like tune this simulation run. But having said that, I think I made a mistake. Now, though I added this vType distribution, I don't think I have mentioned that. So here, what happens is that so in the vehicle type distribution, I mentioned it, but it has to be here. It has to be in the observed rather sorry it has to be mentioned here, right? So vehicle id and vehicle type has to be drawn from this vehicle type distribution. That information is missing. So actually that is a mistake that I did. So uh, now these videos that I create are not edited at all, right? So these are in real time, in reality, these type of errors you can also can happen, right? So therefore this gives you kind of a feeling as to on reality how things happen, right? So let's add that. Type is equal sign and then backslash, and you can give that whatever the name that is given over there, right? So base, so I can close it. Put a space over here. Yeah, should work. Let's run this and see. So what happens here is that for your root file, for the vehicle type dist base string will be added. So then when you couple it with the when you give your actual vehicle type distribution in the SUMO configuration file, it will work together and give you the expected result. So let me try to show that. Yeah, so you have something like this now, right? Now you have this over here and your vehicle type distribution, you have the same distribution, so it can sample, it can generate vehicles that matches this probability. So two things has to be make sure, like basically three things. This ID here, or rather two things, this ID here and whatever you have provided here should match, and as well as you need to point the vehicle type distribution file to the SUMO configuration file. So let's run this for one last time and see whether there's some like improvement. So I guess now you will be seeing different types of vehicles. If I take a snapshot, right? So you have very small vehicles, like this could be a motorcycle, right? You can check that, show vehicle type parameter. So that is a motorcycle over here. And here it's a truck, right? So we might have, this might be a tuk-tuk. No, it's a passenger car. So see whether you can find something from here. Probably this. It's a passenger car. See whether you can find something smaller, maybe this. Right, that's a motorcycle, right? So here's a motorcycle. Right, so all the vehicle types are there, right? So let me quickly run this. Yeah, so now I think all the time a very low number of vehicles are there in the network, right? So whatever vehicles that comes in, like quickly exit from the network. So that's a good sign. So 3000 simulation seconds. 3,600. So now we see clearly the vehicles are clearing so quickly, right? So 4,100. So we came as close as possible by adding this vehicle type distribution as well. Right. So just to recap what we did here, right? So we wanted to, our intention was to reduce the simulation time as much as possible. So in an earlier episode, I guess we brought in these elements, right? And then that also did not. I mean, it reduced. It had an impact, but the changes or the results were not visible. So the results were visible once we add the traffic signal timing plan and as well the vehicle type distribution, right? So so traffic signal plan, you can directly add it over here, but the vehicle type distribution, you have to map the file obviously over here, and also you need to, when in the root sampler, you can pass it as an attribute, so it will be written as a basically text string, or rather as a placeholder. So that would then can sample from the uh, vehicle type distribution file that has been provided. Right. So that is what I wanted to cover in this tutorial. Right. So if you find these tutorials are useful, please consider subscribing to my channel. And in the next video, we'll see how we can bring in a public transport line and bring in the public transportation service as well to this simulation. Right. So we'll see you on our next video. Thank you.